Hello, this is an overview of our submitted research on analyzing human perceptions of a MEDEVAC robot in a simulated evacuation scenario. To provide some background, medical evacuation entails the acquiring and transportation of wounded or ill persons to safety. This is a common problem in both military and urban contexts. Notably, these operations often take place in hostile environments, which pose life-threatening risk for first responders. However, the use of autonomous systems in this domain can offload risk from rescuers. Unfortunately, research on MEDEVAC technology usually emphasizes platform design or autonomous capabilities, but in general overlooks key insights from human-robot interaction. The HRA literature suggests that human perceptions of a machine teammate directly impact the machine's performance. Following this, we explored which factors of a medical evacuation scenario impacted human perceptions of a MEDEVAC robot. Accordingly, we developed our own MEDEVAC robot. The robot was built from a Ubiquiti Magni platform. We attached a Hover 1 Beast Buggy as a seat, and utilized a Hikoyo 2D lidar with an Intel RealSense RGB camera, which functioned for navigation and object detection. We designed a real-world evacuation scenario, bringing in subjects in pairs. Each subject was assigned the role of bystander or casualty. During each trial of the experiment, the MEDEVAC robot navigated an 11-meter path, acquiring the casualty and returning them to an ambulance exchange point. This required the robot to avoid an idle bystander en route. Trials were varied by the robot's operating mode, which was defined by its speed and its level of autonomy during each run. After each trial, both subjects completed a questionnaire. The questionnaire recorded subject ID, role, and the operating mode that was used in the most recent run. Question 1 was largely derived from the Godspeed scale, and was designed to measure emotional states. Question 2 measured general perceived safety on a scale of unsafe to overly safe. Question 3 also pertained to safety, but broke down the different parts of the run. And finally, question 4 included 16 different items designed to measure social compatibility with the robot. These are derived from the numerous scales mentioned in our paper. We collected data from 61 subjects. We processed the Likert scores and conducted parametric and non-parametric statistical tests on our data to see if operating mode or role had any effect on responses. We found consistent effects of operating mode on scores from questions 1 through 3. Pairwise comparisons indicated that the autonomous fast operating mode resulted in lower reported emotional states and perceived safety. The autonomous fast operating mode was visibly faster than the other modes. We can see here that the robot overshoots its turning location at point B. This brings the robot uncomfortably close to the bystander, before correcting and heading for the casualty at point C. Errors like these help explain the negative impact of the autonomous fast condition on subject responses. In contrast, the autonomous slow condition generated the highest average Likert scores across all subjects. The teleoperation condition also resulted in relatively high scores, although we see a difference between bystander and casualty responses for questions 1 and 3. Casualty responses were significantly lower for this condition only, indicating that their direct interaction with the robot negatively impacted their emotional states and perceived safety by event. Future implementations of MEDEVAC technology should be careful not to sacrifice positive perceptions for speed.